All right, mathletes, here we are looking at translations. So translation is a type of transformation that moves every single point fixed distance away and preserves size and shape. We can call that an isometry, but here we just need to know that it always keeps the same size. Okay, so when we talk about these transformations, we're going to use vectors. So vectors have a horizontal movement and a vertical movement. The horizontal movement is a number up top. The vertical movement is the bottom up on the bottom, and we're going to want to make sure we put parentheses around there. So you can see for this rectangle up here, the first object we have is in the green. Okay, notice that's the original object, and we call after the transformation the image. Okay, so we can see this object moved 4 to the right. Okay, and right's positive, left's negative, just like on our coordinate plane. And then a vertical movement of -3, we're going to move the object down 3. And just like on the x and y axis, -3 is going down. Okay, so if we want to know the total distance that this object has moved, we can use the Pythagorean theorem. So how far did it move from here to there? Well, we can use 4 squared plus -3 squared equals our distance squared. We get 16 plus 9, which is equal to our distance squared. Notice every time we square a negative number, we're going to get positive. So 25 is equal to our distance squared. So we can see, after taking the square root, that this transformation has moved us 5 units in that direction. Okay, so that would be the magnitude. Vectors deal with direction and magnitude. So the magnitude of this vector, the size of it, is our distance of 5 for this example. Okay, let's look at another example here. So translate this object by a translation of a vector of -5 and 2. So when I think of -5, that's my horizontal translation. So I'm going to go over 1, 2, 3, 4, 5. Okay, and I'm going to go vertically up 2. So that's 1, 2. So I'm just thinking about moving this 1 point. So that 1 point moves right here. So since it's preserving size and shape, I know that this shape goes up 2, over 3, okay, up 2, down into the left 2, and then a single diagonal there. Okay, and I can see that the same thing worked for any one of the points. I can double check. So this point over here, we went left 1, 2, 3, 4, 5, and then we went up 1, 2. Okay, so this is what we call A primed because that is our image of our original object. Okay, so to figure out how far the object is moved, we just take our parameters and we have -5 squared plus 2 squared equals our distance squared. Okay, well, anything negative is positive, so we just get positive 25 plus 4, which is 2 squared, equals d squared. So we get 29 is equal to d squared. So d is equal to the square root of 29. I'm just going to leave my answer as a radical form. So that's how far the object is moved from A to the image of A. Okay, let's look at our next example. Okay, so we can also do this on a coordinate plane. We don't doesn't matter if it's just on graph paper or any platform we can translate objects. We just need to make sure that that translation always preserves size and shape. We can also think of it as a slide. Okay, so we're going to just translate the quadrilateral ABCD. Okay, 2 units to the right and 4 units up. Okay, so as we translate this, okay, I'm just going to translate A first. So I'm going to go 2 units to the right, 1, 2, and 4 units up, 1, 2, 3, 4. So that point there is A primed. That's the image. Now I'm going to do B. So I'm going to go over 1, 2, up 1, 2, 3, 4, and there is my B. Okay, so I can do that for every point, or I can just recognize my shape as being a trapezoid. Okay, and I can just, because it preserves the same size and shape, I can see that A to D is 4 long. 2, 4. So I know that this point here is going to be D primed. And I can also go over 2 here, and this is going to be C primed. Okay, and if I connect the dots, and there is my image of my original object. If I use a translation vector to describe this translation, I know that I'm going to stack my numbers. This top number is my horizontal translation. 2 to the right is positive. Okay, so that's a 2 on top. Right's positive, and 4 units up, and then up is here, or vertical, and since it's up, it says positive as well. So that is our vector. Okay, state the vertex coordinates of the image of the quadrilateral. So state the coordinates. So I can look there and say, all right, A primed is the coordinates of -2. Sorry, that's -1. And 3. B prime, the image, okay, is over 1, up 1. C primed is over 1, down 1. Okay, and D primed is equal to left 1 and then down 1 as well. So those are my coordinates of the image of the quadrilateral. Okay, let's look at one more example here. So this is asking, is this transformation a translation? Okay, so if I look here from B to B primed, I went up 1 over 3. So each point should be the same. So up 1 over 3, so that's true for B and A, but C is up 1 over 3, and that's not C prime. So this is not a transformation. Another reason I can also argue that it's not a transformation is it did not preserve its size or shape. Okay, if we look at this image, okay, we have 2 different triangles. So when we're doing a transformation, okay, or this translation, we should always preserve our size and shape. Here we have 2 different size triangles, so it's not a transformation. All right, that concludes our notes today. Please highlight any questions you might have and bring them to class tomorrow.